Alright, here we go. This is Scholar Strive doing some math today in Algebra 1, my unit 2.2, or Chapter 3 in that red kayak book. We're finally getting to the big stuff in algebra, where we're learning how to solve one-step equations. So, let me go over some vocabulary really quick. So, reciprocal. Reciprocal is two non-zero numbers whose product is 1. So let's say I have 3/5 and 5/3. When I multiply them together, I get 15 over 15, which is 1. So basically, if you have a number, you just flip the numerator and denominator to get the reciprocal. So if I have 2/3, I just flip it, and my reciprocal is 3/2. Equivalent equations that have the same solution. That means like x equals 5, and it works for both those equations. Inverse operations. So two operations that undo each other. So let's say I have 9, and I add 3. That equals 12. I can undo it by subtracting 3 to get back 9. Multiplication and division, they cancel each other out. If I start by 9 and divide by 3, I'll get 3. I can undo that by multiplying that same 3 back to get 9. So adding and subtracting are opposite or inverse operations. Multiplication and division are opposite or inverse operations. And then we're going to look at these 4 properties. And basically, we're gonna do examples and work through this to explain these. But basically, this first one says, so let's say I have an equation. X plus 3 equals 9. Don't worry about the answer here. But basically what it says is, I can add anything to both sides of this equation. So when I'm talking about sides, there's the sides of the equal sign. So there's the left side and there's the right side. And what this says is I can add anything I want to both sides. So actually, let me change this really quick to minus 3. So I can add 3 to the left side as long as I add 3 to the right side. This one says I can subtract from both sides as long as it's the same number. Multiplication says I can multiply any number to both sides as long as it's not 0. And same thing with division. I can divide both sides by a number as long as it's not 0. So let's do some examples here. So you're going to be running into problems in the book, and it says solve for x. And what does that mean? Well, we want to know what x is, but in algebra, we want to get x alone. And we use inverse operations to do this. Alright, so step 1, most likely you'll be pulling problems from the book. So step 1, rewrite equation. So write equation. So let's say step 1 is complete. Y plus 3 equals 10. Okay. So step 2, we need to get y alone. Okay. So in this one, we're going to get y alone. How do we do that? So we're going to use inverse operations. Okay. So I look at this plus 3. I want y by itself. I want to get it alone. So how do I get rid of this plus 3? I'm going to subtract 3 from both sides. Because to get rid of it from the left, I'm going to subtract 3. If I do it to one side, I must do it to the other. So get y alone using inverse operations. Okay. So once again, let's start over. Step 1, you write the equation. In step 2, we want to get y alone. We see a plus 3. What's the opposite of adding 3? It's subtracting 3. Okay. So we have to do it to both sides. So 3 minus 3 is 0, so it goes away. And then we're left with y equals 10 minus 3 is 7. Okay, so this is considered a one-step equation. I know there's 2 steps, I wrote 2 steps there, but if you already have the problem written down, then you just have 1 step, right? Y equals 7. Now, you're probably saying, well, I could have done that in my head. What number plus 3 is 10? That's 7. Now remember, like I said before, we're using easier equations to teach you how to do this algebra thing, this method. And that way you can use this method in the future to help you with more complex problems. Okay, so also it also tells you if you're doing it right, because you know that the answer should be 7. So if you do the work and you get the wrong answer, that means you messed up somewhere. So what number minus 9 is 11? So we know that t is 20. But how do we show our work? Okay, so we write the equation, and then we do the inverse operation. So t minus 9, we're going to add 9 to both sides. So make sure you show your work here. I want to see the minus, right here I want to see the plus 9 to both sides. If you want, you can create a little barrier to help you figure out your sides. And so we have t equals 20. Okay. So negative 9 plus 9 is 0. 11 plus 9 is 20. All right. Let's move on to the next, or whatever the next page is. All right, solve the equation. That means we have to get the variable alone. So a plus 6 is 17. So that means we're going to subtract 6 from both sides and get a equals 11. So b minus 17 is 12. I'm going to add 17. So you're just doing the opposite operation to both sides, and you must do it to both sides. Otherwise, the equation is not the same. So b equals 29. Okay. So x is on the right side now. It doesn't matter. Doesn't matter if x is alone on the left or on the right. We just do the same thing. We're trying to get x by itself. Whatever is easiest. Minus 2, minus 2. So x equals negative 5. If you prefer x to be on the left, you can just write it on the left just like this. Doesn't matter. Either answer works. Okay. Opposite operation of minus 4 is plus 4. Y equals negative 2. Okay. So here comes the division property of equality in part A. So what times 8 is 56? So if you go over your times tables, 8 times 1, 8 times 2, blah, 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 you'll know that this x equals 7 down here. But how do we show it algebraically? So the division property of equality says this: we can divide both sides by a number. So once again, we're trying to get x by itself. Always getting the variable by itself. And then we use the inverse operations to do that. So what is the opposite operation of multiplication? That's division. So instead of 8 times, we're going to divide both sides by 8. So 8 divided by 8, those go away, and I'm left with x. 56 divided by 8 is 7. Okay? So now we have a divided by 5 equals 12. What is the opposite operation? Multiplication. So I'm going to multiply both sides by 5. So how do we show that? Just ignore the b here. And I would multiply by 5. So dot 5. Not decimal point, but dot. And then dot 5 on this side. Or you can say I don't like to use x, but you can use x if you like, but I'm just saying multiplying by 5. Okay? But what happens is that these will cancel. And then I'm left with a equals 12 times 5, which is 60. Okay? Example 4. Multiply the whole number and a fraction. So, remember, I've already done this before, you always change your whole numbers into a fraction by just putting it over 1. So 2 over 1 multiplied by 3 over 4. Multiply for two fractions together, always multiply across the top and across the bottom. And then you want to reduce the fraction. Both of these can be divided by 2. So I get 3 halves. Alright, example 5. So what if we're multiplying by a fraction? Okay. So one way to look at this, so you can either do it in 2 steps or you can do it in 1 step. So I'm going to show you 2 steps first. So what I like to do is think of c as over 1. And then I multiply the fractions together. So I'll get 3c over 5 equals 6. Okay? So this is method 1. Method 1. Okay? So now c, trying to get, so the end goal is to get c by itself. So c is being divided by 5, so I'm going to multiply by 5 to both sides. These will cancel, and I'll get 3c equals 30. And then I can divide by 3 to both sides, because c is being multiplied by 3, so I divide by 3, and I'll get c equals 10. 30 divided by 3 is 10. So that's method 1. Method 2. Method 2. Okay. So we have 3/5 times c equals 6. So what they want us to do is multiply by the reciprocal. So remember the reciprocal, I should have used different colors. So 5 over 3. That's the reciprocal. So I want you to multiply by the reciprocal to the left. Multiply that same reciprocal to the right. Oops. Now, please tell me I'm recording. I am? Okay, good. So these will cancel out. I'm left with C. And then I have 6 over 1 times 5 over 3. So that's 30 over 3, which is 10. Okay? It's okay if you do method 1. I'll be happy with method 1. If you could do method 2, I'm happy with method 2. But you do have to show all this work. You don't have to show both methods, but for method 1, I need to see you multiply both sides by 5, and then you need to divide both sides by 3, and then I get a boxed answer. Method 2, the work I need to see the reciprocal being multiplied to both sides. Alright, let's do some more examples. So I'm just going to use method 1 for this, because this is just b over 4 equals 13. So I'm going to multiply both sides by 4, and I'll get b equals 52. Okay. This one, I'll use method 2. So we got a negative sign. So remember, reciprocals just flipped. So I'm going to use a different color. So I'm still going to flip the fraction. So it's going to be negative 8 over 3 times negative 3 over 8m equals 21 times negative 8 over 3. And let me rewrite that, because I wanted certain things in black. Negative 3/8m equals 21. Okay, I'm multiplying both sides by negative 8 over 3. Okay, the left side will cancel, because 8 divided by 8 and 3 divided by 3 is 1. And then negative times a negative is a positive. So m equals, okay, so this is 21 over 1. So remember, back in the fraction days, so you can multiply it straight across the top and then divide by 3. You can do it that way. Or if you remember, 21 divided by 3 is 7. So this becomes 7, and that becomes 1. And I'll get negative 56. Now if you do it the original way, you do 21 times negative 8, and you'll get some big number. So you'll get negative 168 divided by 3. And then that'll give you your negative 56. Alright, hopefully, make sure you practice on those step 1 equation. If I'm if the variable is being added, then you subtract. If it's subtracting, it's adding. If it's multiplication, it's division. Division, multiplication. Trying to get the letter by itself. Alright, have a good day.